G'day viewers. Today's little video is going to be about antimatter, specifically about what you call mutual annihilation. It occurs between a positively charged electron and a negatively charged electron. J.J. Thomson proposed that the negatively charged electron, this one here, should be called a negatron, but apparently people didn't like that. They stuck with the original, before they discovered the positron, they stuck with the original name of electron. But here we have a positron down here and an electron here. Now, this is supposed to be the dawning of the age of Aquarius and the age of enlightenment, but I'm still not allowed to tell you certain things. I've actually done this experiment and done it many times in my quest for reaching super high temperatures, and so we'll just discuss it. What we've got here is the electron, positron and the electron. They collide in the middle here. Now these are generated by accelerating high voltage electrons into a metal target, and what you end up with in the center is the mutual annihilation. Now each positron and electron carry the exact same amount of energy. They're just mirror images of each other, and that is 511 and so blah blah thousand electron volts, keV. 511 kevs. Anyway, so we've got 511 kev there, 511 kev here, and the annihilation or the collision, these two are attracted to each other because they're opposite charges. Once they get into the vicinity of each other, they actually accelerate. So they travel along the y-axis here. This is a two-dimensional representation of a three-dimensional space. So I hope you can visualize that. So these two annihilate in the center, and this is where it gets interesting, because according to some people this shouldn't happen, but what happens is we get two photons. One photon, one antiphoton. They're basically travelling, spiralling away from the centre at right angles, and the same with the two neutrinos. One anti-electron neutrino and one electron neutrino. So this all conforms to the right-hand rule, and you can work out the charges and the directions and the velocities, but the important thing to remember is that we've got 511 keV here and 511 keV here. That gives us a total of 1022 keV, right? Just over 1 million electron volts. So that's just drawing it out and showing you what happens. This is quite proven because these two the photon pair that's produced, the wavelength is gamma. Very, very short wavelength. So we'll go and find out what the wavelengths are, and we know the energy. The total mutual annihilation energy here is 1022 keV. Yeah, it can be written as 1.022, it's actually slightly above this, million electron volts. I don't even have to look this up, I don't have to Google it, this is in my head, this has been in my head for nearly 30 years. I was doing these sorts of experiments and using a very crudely built accelerator when I had some time off after my dad died. He left me a little bit of money, so I did some crazy experiments, and the more successful I became, the more opposition I got. So I'm expecting opposition on this, but I'm sure if you ask any physicist, they will confirm exactly what I'm saying here. So nuclear fusion might be obtainable one day in the future, not under their current designs, but this is far more effective at generating power. It's not free power because it takes 2 electrons. There's your cost. Your cost is in your electrons, and there's your output. So you get a low energy input, you get a very high energy output. It's way above unity, and if we could make because this is gamma radiation, it's very, very dangerous. You need probably about a metre of shielding, just a metre thick in all directions. So the device is going to be at least 2.5, 2.6 metres in diameter, and that size, you're probably looking at several megawatts output. But anyway, I thought I'd do the whiteboard presentation, so you've got a picture there to reference. You hear me talking about it and trying to explain it in the simplest terms. Now one conundrum we generate here is, if an electron is a fundamental particle, we've got 2 fundamental particles that are supposed to annihilate and produce nothing but energy. So my question is, where do these neutrinos come from? If an electron is a fundamental particle, where do the neutrinos come from in the collision? Now, with my crude apparatus, I cannot detect these neutrinos, but this is what physicists are telling me that happens in the mutual annihilation process. I know, and I can prove, I'm generating these gamma photons because they go through, well, I had 1/2-inch lead plates, it's about 12.5 millimetres. The radiation went straight through those, and I'll write it down here. The beam from here was a 5-degree divergence. Right? 5-degree divergence on the beam. So we're looking at a very, very narrow beam. Now, I told some people about this, and I told them not to try it at home. They didn't have the necessary equipment. I know they tried it at home because I think they're dead now. This is lethal radiation, what we're talking here. If you expose yourself to this, you will get sick, you will die. Okay? Now, I did a lot of this from a distance, standing away from the beams, off to an angle. These beams ionised fluorescent tubes through lead plates, 1/2-inch lead plates. So this is very dangerous energy. I don't want you to try it, I just want you to look at what I'm presenting here, and I'll write it here, so there's no, this is antimatter. Now we can do the same with atoms, but I'm not allowed to show you how, I'm not allowed to show you I can basically make the statement, but I can't divulge any of the technical information, and that's due to representatives of the government visiting me a few years ago and telling me what I could and couldn't tell you. So read my body language. I'm 100% A1 on this. I don't want to go to jail, alright? So this is the antimatter, simplified antimatter interaction, mutual annihilation, and we'll go and do some more math on this and show you exactly what I mean. Now, this is probably the most efficient way to generate energy. It's way more efficient than fossil fuels. It's almost hazard-free if it's treated with the right safety constraints. It's harmless. I'd like to see facilities built underground so there's no chance of this stuff leaking out into the environment. What else? Yeah, that stuff we can have here now. I could build you one today. I could build you one in a matter of hours. I've got all the gear here. I only have to put it together, and yeah. So that's my little presentation on electron mutual annihilation. Argue against it if you want. You're welcome to. I don't care. Put your arguments up, and I'll give my point of view and see how we go. But yeah, that's the sort of stuff I'm into.